Other civilizations like ours probably won't advance technology far enough to create simulated realities, or creating simulated realities is impossible in the first place. In the second scenario, creating simulated realities is possible, but if a civilization creates one, it won't make a lot of them, because it requires too much processing power, or there's some other kind of limitation. And finally, creating simulated realities is possible, and there's no limit on how many get produced. These simulations would be entirely indistinguishable from ordinary reality. If we're in this scenario, we're almost certainly living in a simulated reality right now. The sheer number of simulated realities would outnumber actual reality by so much that the probability that we're in actual reality would be very close to zero. Now, Bostrom's argument makes a lot of pretty hefty assumptions. The first one is that mental states don't depend on their physical instantiation. Our current conscious experience happens to emerge from biological neural networks in our brain, but according to this view, this doesn't have to be the case. If we could create a silicon processor in a computer with the exact same neural network, the same conscious experience would arise. Consciousness is a matter of information processing. There's nothing more going on. This is known as substrate independence. To be clear, this is a pretty controversial take. A lot of philosophers of mind believe that consciousness isn't reducible to computation. Some believe that consciousness does require a specific kind of substance for it to emerge, like a brain. But for the purposes of this argument, we'll assume substrate independence for consciousness. Bostrom also spends some time in his paper laying out some concrete numbers, showing how the simulation might be done. If it does end up being possible, it will be really hard. But if we assume that technology continues to progress and accelerate, it doesn't really matter how long it takes. Based on how much computing power it takes to replicate a single piece of neural tissue, we would need a computer that could perform about 10 to the 14 operations per second to replicate a human brain. Other estimates sit a bit higher, at 10 to the 16 or 10 to the 17. We'd have to generate some kind of environment for that brain too, and this really depends on how thorough we are with environmental simulation. At a minimum, we'd have to replicate the ordinary interactions humans might have with each other, or their environment. We couldn't program every single subatomic particle in the universe, so a lot of stuff would have to be left unrendered until a human came by to observe it. Based on all of this, along with a hypothetical computer design that could perform 10 to the 42 operations per second, Bostrom figures that civilizations in the distant future could indeed create simulations. There's nothing in principle preventing this from being possible. Now, for the record, I'm not personally sold on the simulation argument. I'm not sure substrate independence is true. And I also don't know that it's a guarantee that civilization will continue developing forever. With climate change, resource depletion, and nuclear war, it's